You are pulling a cotton shirt from a cardboard box in the corner of a room. Your dog is 3 inches away, her head lowered as she presses her nose into the faded fabric. She remains perfectly still while her nostrils flutter in a high-frequency rhythmic motion. You believe she is simply exploring a new scent in a dusty environment. You assume she is incapable of recalling a person she has not seen in several years. This is a cognitive misunderstanding. What you are actually witnessing is the retrieval of an episodic-like memory through a sensory trigger. She is not just smelling fabric, she is accessing a stored emotional profile. This interaction is governed by a specific neurological process called the affective temporal link. We will deconstruct the myth of the canine short-term memory and replace it with a map of their emotional archives. Let's begin. The canine brain processes memory through the limbic system, a network responsible for emotional response and behavioral regulation. Unlike the human brain, which often organizes data into a chronological narrative, the dog brain utilizes episodic-like memory to store highly salient emotional events. This process is managed by the hippocampus, the brain's center for spatial and emotional navigation. When a dog experiences a significant event, the brain encodes a cluster of sensory data rather than a timeline of facts. This means information is stored alongside the physiological state the dog was in during the original encounter. This chemical foundation allows for a process called consolidation, where memories are moved from short-term to long-term storage during the REM sleep cycle. This biological structure ensures that safety signals and social bonds remain permanent features of the dog's internal world. Consider the first scenario, where a specific sensory key unlocks a distant archive. You are in a public park when a family member you have not seen in 4 years walks toward you. Your dog is currently engaged in a game with a tennis ball, but she suddenly drops the object and stares. She approaches the newcomer and leans her full body weight against their shins, her tail moving in a slow, low-frequency arc. Most owners believe the dog has a visual memory of the person's face, like a human would. You assume she is thinking about the specific walks they took together in the past. There is a wide gap between this assumption and the clinical data. A 2014 study in the journal Behavioral Processes found that familiar human scents trigger immediate and direct activation of the caudate nucleus. The caudate nucleus is the brain's primary reward center that manages positive expectations. The neurological consequence in this moment is a profound chemical reactivation. As the person enters the space, they are broadcasting a specific chemical profile that the dog's olfactory bulb captures and sends directly to the amygdala. The amygdala, which handles emotional appraisal, recognizes this data as a secure base signal. This immediately overrides the dog's current state of play. Inside the brain, the caudate nucleus releases a surge of dopamine, the neurotransmitter associated with pleasure and reward. The dog is not remembering a list of historical events or dates. Instead, she is experiencing a sudden, systemic return of the exact physiological safety she felt 4 years ago. Her heart rate begins to synchronize with the person's presence, and her autonomic nervous system shifts from a state of general alertness to one of specific social rest. The dog is essentially reoccupying a past version of herself. This memory is a physical script that her brain is simply following because the chemical trigger is present. This behavior functions like a key turning in a lock that has not been touched in a decade. You can maintain this link by allowing the dog to sniff the individual thoroughly without interruption to stabilize the chemical retrieval. Scenario 2 involves the navigation of a forgotten physical space. You return to a vacation home after 8 months of absence, and the gravel of the driveway crunches under your tires. Before you can even reach for the leash, your dog runs to a specific hidden corner of the property where a trail leads to a creek. She ignores the closer, more obvious backyard and waits by a narrow gap in the fence she used the previous summer. Most owners assume the dog has a mental map and is consciously planning a trip to the water. You assume she is thinking about the specific temperature of the creek or a previous game. But the 2016 study in Current Biology by Fugatsa and colleagues demonstrated that dogs possess episodic-like memory, allowing them to recall complex actions and locations without expecting to be tested. The neurological consequence is a spatial temporal loop within the hippocampal circuit. As the dog's paws make contact with the gravel and her eyes scan the horizon, the environment acts as an external hard drive. These visual and tactile cues trigger a high-speed firing sequence in the parietal lobe, which manages spatial awareness. The brain is not planning a future trip. It is being pulled through a sensory memory sequence that was encoded during the last visit. This causes the dog's heart rate to increase as the brain prepares the motor cortex for the expected sensory payout of the creek. The dog is not remembering the creek as a concept. She is re-experiencing the motor instructions and the dopamine reward associated with that specific path. This is a biological instruction manual that the physical world is reading to her in real time. Her brain is mirroring the state of readiness she felt months ago, making the memory a physical command. The environment is a series of triggers that the dog's brain interprets as a mandatory path. To help her manage this, introduce slight variations in old environments to keep the cognitive pathways flexible and reduce high arousal memory loops. The third scenario demonstrates the power of an acoustic memory anchor. You are playing a video clip on your phone from several years ago, and your voice on the recording speaks a specific nickname in a high-pitched, melodic tone. Your dog is in the other room, but she immediately sprints toward the phone and tilts her head with her ears pushed forward. You believe she is looking for the person inside the phone or is confused by the sound. You assume she understands the specific words being spoken in the recording. However, a 2016 study in the journal Science found that dogs process emotional tone in the right hemisphere of the brain, completely separate from the meaning of words. The neurological consequence is a state of social dissonance triggered by a limbic bypass. The recorded voice hits the auditory cortex and immediately activates the right hemisphere's emotional processing centers. This acoustic signature is linked to a stored state of social safety, causing a temporary surge in cortisol as the dog enters a state of high-intensity scanning. She is looking for the source of the biological regulator, you. Because the current version of you is silent, her brain experiences a conflict between the memory trigger and the current data. The head tilt is a clinical effort to change the angle of the ear canals to more accurately localize the source of the memory. Her brain is searching for the physical presence that belongs to the emotional anchor she just heard. She is responding to a vocal ghost. This sound is a bell ringing in an empty cathedral, echoing with the memory of a crowded room. You can use this effectively by maintaining consistent, distinct vocal cues for positive interactions to create permanent neurological anchors that help her regulate her anxiety during stress. The fourth scenario examines the long-term impact of memory on the dog's baseline health. You have lived with your dog for several years, providing a consistent, low-stress environment. She settles into a deep sleep the moment you sit down, her back turned to you. You assume she is just tired or has a calm personality. You believe her behavior is just a habit she has developed over time. The gap here is that this behavior is actually the result of thousands of encoded positive memories that have reshaped her brain. A study in the Journal of Veterinary Behavior found that dogs with a secure attachment history show higher markers of hippocampal neurogenesis. The neurological consequence of this chronic, positive encoding is the physical fortification of the trust circuit. Every time you have provided a soft, mutual gaze or a calm interaction, the dog's brain has consolidated those moments during REM sleep. This process prunes away the data of minor stressors and strengthens the neural pathways associated with your presence as a safe harbor. The dog is not just well-behaved. She is a biological system that has been optimized by your consistency. This lowers her baseline heart rate and prevents the rapid shortening of telomeres, the protective caps on her DNA. Her brain has classified you as a permanent ally, allowing her to shut down her threat detection system. She is aging more slowly at a cellular level because her memory of you is one of absolute stability. The dog is a geological formation shaped by the steady pressure of your calm. To maintain this, avoid erratic punishment or high-intensity scolding, as a single high-cortisol event can be encoded more strongly than 100 calm ones. We have reached the core of the canine memory system, the affective temporal link. The primary misunderstanding of canine cognition is the belief that dogs live only in a vacuum of the present. The research from current biology and science proves that dogs possess episodic-like memory. They do not remember the dates on a calendar, but they remember the biological state of being with you. When she sniffs your old shirt or hears your voice, she is not just reacting. She is returning to the safe harbor you built for her. Your scent is the compass she uses to navigate the uncertainty of the world. She will never forget that being with you felt safe. The dog does not remember the dates on a calendar. She remembers the safety of your scent.